I have gone through nearly all basics of spanning tree protocol or per VLAN spanning tree protocol implementation on Cisco Catalyst. What's left is Uplinkfast and Backbonefast. But before I get there, let's do a quick recap. A spanning tree, all flavors that Cisco offers, follows pretty much the same rules when it comes to selection of a root bridge as well as designated and root ports and alternate ports. So the root bridge election is based on the lowest bridge ID. So when they all start in the listening state exchanging BPDU frames, the the one that wins election is the one that has the lowest bridge ID. Bridge ID consists of the um, priority, and let's see that maybe on the command line interface, say show spanning tree VLAN 1, and let's go for section root ID or bridge ID. So on switch 4, I can see that switch 4 MAC address, its priority for VLAN 1 is 32769, and its MAC address is AABBCC001400. The root bridge, the lowest bridge ID, has also the same priority in our topology, but its MAC address is lower. It's 11 versus 14 here. That's why it won the election. So 11 is the root bridge, switch 1. That's 12, 13, 14. This one becomes the root bridge. We also saw that the next step is to select the root port. So switch 3 selects E4/2, and let's again see that quickly on the command line interface if I jump to. So switch 3 receives BPDUs on 4/2, 4/3, 5/0, 5/1, and 4/0 and 4/1. Now this one becomes the root port obviously because the cost of the port towards the root bridge is 100 and the cost of the BPDU coming down here is 0. Root is sending its own BPDUs with a cost of 0, and root is the one that generates BPDUs. Each switch adds its own best cost while sending this to its neighbors. So let's see that quickly on the command line interface as well. So if let's just say switch 3 has a choice, so if I go show spanning tree, interface E42, and let's go for detail, and for 3, so these are the 2 links. Let's look at the 3 potential links here, and let's go 50, and 5051 would be pretty much the same cost from switch 2, so we're gonna go for 50. So this is a quick thing. So if let's say BPDU comes here and switch 1 already selected this as a best root port, best cost towards the root bridge, it adds its own cost to the 0, which is 100, and 100 cost is going to be sent down here. Let's see that. So the local cost of the port 50 is 100. The one that is received from the designated bridge, which has the priority address is 12, which is switch 2. This is the sender or forwarder of the BPDU, I should say. And its cost is also 100. So 100 plus 100 local cost, it's 200 in total. Whereas these two offer better cost. So they are sent by both by switch 1, 11, 11 MAC address, and local cost of the port here is 100. So this cost here is 100 plus received from the 11 designated bridge is 0. So 0 plus 100 is 100, but so is this one. Local cost of the 4.3 port is 100 and received is 0. So the tiebreaker would be the priority of the port that is sending BPDU. This priority here is 128, and this priority here configured is also 128. The tiebreaker is the 19 is this port identifier, and here is 20, so this one becomes blocking and this one is forwarding. Lower is always the better. And these rules pretty much apply also for designated port selection, so we've gone through that already. Those same rules will be applied in all spanning tree flavor that Cisco has implemented on their switches. So if I want to change the mode of operation, there's three modes of operation. The rapid PVST is the one we use, which is signified with also IEEE. Sorry, PVST is the IEEE. Rapid PVST is pretty much the evolution of that, and if we are to choose the protocol, this is going to be probably the protocol more likely than PVST. And there's another option, which is the multiple spanning tree protocol, which we're going to cover later. So just to finish, the PVST or IEEE protocol offers two more features, and I want to cover one more here, which is Uplink Fast. Uplink Fast is a similar to Portfast we implemented, except that because it tries to decrease the time of convergence, but it's not jumping or skipping any listening and learn state like Portfast does. In fact, it cannot do that because it's a switch connection, but they wanted to shave off some time when the root port is going down and the system has an alternate port towards the root bridge. So that is the situation. So the Uplink Fast will be implemented on all leaf switches if someone chose to use PVST. Now, this Uplink Fast and Backbonefast will not be used in rapid spanning tree because the selection of everything works differently. So Uplink Fast and Backbonefast is only features enhancements of the PVST or IEEE flavor. Now, how does it work? Instead of, okay, let's see how it works by default. So if, let's just say, for the argument's sake, switch 3 loses root port 4/2, we're gonna wait 30 seconds, 15 seconds of listening, that's forward delay, and another forward delay, which is learning, another 15 seconds. Let's just see that happen, maybe. Do debug, spanning tree, events. So if I jump to interface E42, and let's display do show spanning tree, interface E42 first, that's the root port, and 43 is the alternate port. So we have an alternate path towards the root bridge that is already calculated. Instead of waiting 15 seconds listening, 15 seconds learning, it will jump to forwarding immediately. How's it going to be working without Uplink Fast? It's going to be, let's go to do debug spanning tree events. I think I did that already. Events, and shut this port down. So let's see what happens. So port 43, the alternate port, goes listening. So if I do display that, it's listening currently. And the traffic is not being forwarded because we're trying to ensure that the selection of the topology is loop free. Now it goes learning. So it's a root port, but it's still learning. And at this point, selection of everything is done, but we're trying to populate as many MAC addresses as possible in order to avoid excessive flooding. And that's what Portfast does as well. And the topology change notification is not going to be sent, and we're not going to flush any MAC addresses, and we're not going to be doing excessive flooding. Now it's forwarding, so no shut, it goes through the same pretty much procedure. So now when we enable Uplink Fast, that's a global config command, like I say, and very unlikely that we will use PVST on the production systems, but if somebody has maybe old boxes or something, that would be the option. So spanning tree, Uplink Fast is our command. It does actually a few things. The first thing it does, it will allow us to skip the listen and learn and just jump to forward almost instantaneously. But the switch as a protection is going to do two things. One, it's going to increase all the port costs by this one. I believe it's 3,000 plus this 100. A local cost of a port, and it will increase its own priority. So if I display now, do show spanning tree, and then for VLAN 1 here, and I will go for section root ID or bridge ID. So now we will see that system, upon configuring Uplinkfast, now has instead of 32769, the priority is 49153. Also, the cost of the ports has been increased, so now all the ports are 3100 instead of 100 for bandwidth 10 megabits per second. Now the reason why that is because the switch wants to avoid a situation where it becomes the transit path switch with that feature. If there's some better path, other switches have better path to get to the root, they shouldn't consider that one. So that's the way it behaves. Also, upon losing the ports, the switches exchange information about MAC addresses, so the reconvergence time is, let's say, sub-second or near to second convergence time. So now if I repeat the same thing, so we still have the debug running, interface E42, interface E42. I cannot do 42 this morning. And if I say do show spanning tree interface E42, it's, and 43 is blocking, alternate blocking. If I just shut this down and display that, 43 has immediately become the root port and forwarding. So we don't lose the time. When the root port is down, we immediately open that one and it becomes the new root port.